All right, what I would like to do is show you the eye using eye models. I've got a model of a skull here just for context. This shows you the orbits, that's the eye sockets, and we'll be dealing with the right eye here in context. And so we can compare just a little bit the bony socket that so protects the eye, and what you are seeing here is some of the same bones that would be located right medially on this skull. This right eye is in context, this model. And what can we see from here? Well, we can see the 6 strap-like skeletal muscles that move the eye. They move the eye very, very delicately. It's innervated in such a way it has some of the most delicate movement in the body. I'm holding right here lateral rectus, which allows us to turn the eye to the right. Here's superior rectus, which, as you can imagine, pulls the eye upward. This is superior oblique. It goes through a little pulley, little anatomical pulley, and in fact the nerve that innervates it's called the trochlear nerve, which means pulley. To innervate, by the way, means to provide neurons that stimulate the muscle to move. You can barely see underneath inferior oblique, and then going back, straight back, you can see the beginning of inferior rectus, and if I move superior rectus, you can see it. Also the big optic nerve coming back to the brain, crisscrossing the optic chiasma right here. What we see here is the pathway for tears to drain into the nasal cavity, and that's what we're looking at there, the nasolacrimal duct. Well, the eye has 3 layers. We can see most of those layers on the model, though not all of them. Instead of using this smaller eye, I would like to show you this eye. Happens to be a left eye. How can I tell? I can see the pattern of the muscles. It's just a little bigger and easier to use. The outer covering of the eye is called the sclera. I like to say it's like a basketball. In fact, it's made of the same thing the outer part of the basketball is made out of. If it's a leather basketball, it's dense, irregular connective tissue, quite tough. And sclera, in fact, means hard. The front of the eye, as we know from ourselves, has a window in it. That's the cornea. And the cornea is unusual, and it lacks a blood supply, and so is very, very clear. So that's our outer layer. I'm going to remove the sclera and then point out for you the second layer of the eye. And what we have here is choroid, but in front, blue or brown, depending on your genetics, you have an iris. Iris referring to the blue color of the eye. The opening, the physical opening in the iris, like the hole in the donut, is the pupil. Let me remove for you the choroid layer, and let's see what else is in the eye. When I take this away, I can see that there are 2 major chambers to the eye that contain fluid. And that fluid would be aqueous humor anteriorly in front of the lens, the crystalline lens that you see here. Posteriorly, this plastic model represents clear vitreous humor, which is gel-like. It's one of the most inert substances in the body. It turns over very, very, very slowly, if at all. By contrast, the aqueous humor is much like cerebrospinal fluid. It, in fact, circulates, it's produced, and it is reabsorbed. I'm going to remove the vitreous humor, remove the model of the lens, and here I am in the posterior cavity, and now I can see the third layer of the eye, the retina, which lies very smooth and flat against the posterior part of the eye. Where the optic nerve of vision comes out, we have the optic disc. That's the blind spot. It's a blind spot because there are no receptors on it. Quite opposite, shown in pink, but actually, if you look into the eye, would have a yellow cast, is the macula lutea, which is located in a tiny pit called the fovea. That is where most cones, which are the receptors for color vision, are located. When we focus, we are focusing light that comes into the pupil, into the eye, back here on the fovea or macula lutea. The retina is very vascular, as you can see here, and it does have that color if one looks into your eye. In fact, red eye, when you take someone's picture with a flash bulb in low light, has to do with the pupil being dilated, and as such, this color, the vascular nature of this, reflects back, showing the blood vessels. Now, I want to show you the ciliary body, which is part of the second layer of the eye. If you have your bearings here, this is the ciliary body. The white fibers that you see represent the suspensory ligaments, and so the lens is held in place by the ciliary body. The lens is a very unusual structure. It has long cells, and it's quite clear in a normal person. If it becomes cloudy, that's a cataract. But it fits right like that. And the ciliary body contains muscles that can adjust the tension on the suspensory ligaments, allowing the lens to round up, which it likes to do because it's elastic, or creating tension on the suspensory ligaments, which creates tension on the lens, flattening the lens up.